show you here is a close-up picture, which is the first evidence we have that the comet Kohoutek had a sunward spike. The picture was taken, it's a Polaroid picture, which was made off the white light chronograph TV display. And although it admittedly is very faint, the features that we'll talk about, or have talked about, are evident, at least on the photograph, and I hope that they are on your TV. The first feature, one which is perhaps the most easily noticed one, of course, is a bright dot right in the center, and that's the Comet. The second feature is just the very start of a tail, which you see right here on the right-hand side. And again, that's very faint, but I believe discernible. And lastly, the sunward spike, which comes in from the lower left, maybe 30 degrees below the horizontal. We were able to see this feature. This is perhaps our best picture. We were able to see this feature for 3 different times or so during the time period in which we were observing it on the white light chronograph TV display. Most of the time, just a very bright dot representing the coma is the evidence to us. But this gave us a hint before we went to EVA that we might see a sunward spike, and kept us looking for it. To do tonight is to show you some of the sketches which we've made of Comet Kohoutek. We have no way of giving you live TV of the comet, unfortunately. So we've tried to make sketches from day to day, especially after perihelion, when it became most evident and most dynamic. And in that way, try to relate to you some of the features which eventually will show up on some of the film we bring back, but we hope will give you an earlier insight into what the comet appeared like and its changes. The first one we're showing you here is a overall impression we have, as we did not make sketches at the time, of the comet before perihelion. And again, this is just very crude. It's just meant to give you a data point at which to start out so that you can see the change in the following sketches. Again, a quick look. You see a white ball with just a bare evidence of a tail. When you get a little better dark adapted, you can see a white ball, of course, the coma, and a tail leading backwards. And I would say that the longest we ever saw it, when it was still visible to us, was something on the order of 1 to 3 degrees, depending upon how well dark adapted you were. And this is all pre-perihelion. We're estimating here roughly 10 days or so ahead of time. When it got very close to perihelion, of course, we could not see it either. Here's the way we saw it on our EVA day. We've already given you this picture once before. We've reformatted it a little, though. Also, on an earlier TV just before this, I tried to give you a close-up of what we saw on the white light chronograph TV display, which did have a slight evidence of the sunward spike. What we're showing here is, first of all, the coma very bright to us. The appearance or color of it was yellow, and most noticeable was the yellow-white spike protruding forward. And we say yellow-white because you have the impression there was a little yellow in there, but relative to the coma and relative to the tail, it did not contain as much yellow. The sunward direction is here, and in the TV, which I have shown before this, the close-up, that spike is going towards the sun, which we could talk about further as far as orientation of that picture. Right now I'll press on, though, to tell you a little bit about what this bottom drawing is and what it represents. They're a very crude picture of isophotes, which means just our mental image of what would be equal intensities of radiation. Of course, the center of the coma is the hottest, and then it tends to degrade as you go further out. And then these are lines of equal intensity back here, and they're rather sharp in that they are flat on the back. This is in contrast to what we've seen later on. The size of this was around 4 to 5 degrees that we could see overall. And again, this was the day after perihelion, day 363. On the following day, 364, the tail became much more evident to us. It was significantly longer as the tail swung around and allowed us to see more of it from the side. And it also was the orangest. There is such a word. It was most orange, as we have seen before and after. And the sunward spike was yellow now, very definitely yellow. And the tail was yellow with perhaps a little bit of orange in it. But the coma itself most certainly was very orange. On the following day, the tail was even longer than the previous day, which was 6 or 7 degrees long. Here it was not quite as orange, and we still noticed, as I should have pointed out in the previous drawing, that there is a sunward spike and a little bit of material in between it. The sunward spike had faded quite a bit. I shouldn't say sunward because perhaps that's misleading. It was not always right on the same axis as the tail, which was pretty much anti-solar now, but it was pretty close to it. It was pretty tough for us to estimate which was really pointing straight at the sun and which was straight away, but there was a slight angle still evident between the two. Colors here were yellow-white for the spike in front, and yellow primarily for the coma and the tail. Now, we had some assessment of the length of this by finding out that Venus was 15 degrees away and Jupiter was 19 degrees away. So we had a reasonable way of making an estimate of the length of this tail. And we came up here with an estimate of 7 to 8 degrees. Again, these were pictures or observations out of the command module and one of the windows in the STS structural transition section, window number 3. Now, this day is one thing that really occurred to me as I looked at it. It looked very familiar, and I couldn't figure out why. Until I all of a sudden realized that it had very much the appearance, as we were looking at it, of a rocket which is burning in the upper atmosphere, say the second stage of one of the Apollo series, and you see the very intense white center, which is the exhaust plume itself right close to the nozzle, and then because the atmospheric density is very low, you find that the plume tends to spread out very rapidly, but very faintly around the side, and then you see the major plume protruding backwards. And it looked as though we were seeing a rocket exhaust plume maybe 45 degrees or so off the axis. Again, here are the drawings of equal isophotes, or isophotes, if you will, lines of equal intensity. And here they're more elliptical, as you see. There's, again, what you really ought to do to get a proper image of all these is to integrate, if you will, between these two. Here we've tried to just draw schematically what it is. Here we've tried to put a little more into it in the way of intensity information, but you really have to combine the two. neither one tells the story. This is the first day of the year, the New Year day. And here we estimated the length as decreasing around 5 or 6 degrees. Still yellow-white. And here we could not say that this spike was here at all. Sometimes when you looked at it, you thought you saw it, and other times you didn't. So rather than mislead, we said, well, it's questionable. Maybe our mind's eye pictures it, but our eye really doesn't. And again, we saw this material coming off the side of the coma, which we could not really trace we could not trace this one back, for example, but you could certainly trace the major stream of the tail all the way back. And again, these lines of equal intensity now being elliptical, as opposed to what we saw the first day after perihelion. And lastly, we have today, and here the question is there really a spike at all? And we drew it in yesterday. Today, we can't say there's any at all. Probably not. We could not see it at all, even in our mind's eye. Perhaps we had talked ourselves out of it a day after it had vanished. And the tail, again, is a little bit shorter, 4 or 5 degrees now. And as I pictured it, it tended to be a little bit fatter in my estimation, but again, this is very qualitative. And the lines of equal intensity resemble what we've seen before. And just the general overall impression is that its tail is becoming a little bit shorter, as at least the evidence of the tail is becoming shorter as we move further away from the sun. And also, the color now is just plain white. We see no evidence of a yellow at all. Okay, Bill would like to add something.
Ed has it in the drawing. The tail, as you see here, has a sort of a ragged appearance. And this was the first thing that impressed me, that the fact that it was fading and the tail was taking on a ragged appearance back toward the tail, the end of the tail.
Well, that's it from now from Kohoutek Observation Headquarters. We'll try to keep you up to date as we see any changes. It's been most interesting for us, and we hope we've been able to give some useful information to you on the ground. I wish you all could see it.